PyTorch is installed, and now it's time for the fun part. In this guide, you'll train your very first neural network. We'll build a classifier for 10 types of clothing, from zero code to a working AI. Let's get started. Here's what we'll build. A neural network that looks at a grayscale photo of clothing and tells you what it is. We'll use the Fashion-MNIST dataset, 60,000 training images, and 10,000 test images. Every image is 28 by 28 pixels in one of 10 classes. Tie shirts, trousers, dresses, sneakers, and more. Let's train a model that recognizes all of them.
Before we write code, let's check your setup. Open a terminal and type Python -- version. It should print Python 3.14.7, or any version from 3.10 up. Now check PyTorch. Type Python-C, import torch, print torch __ version.
It prints 2.13.0. Your environment is ready.
Next, open your editor and create a new file called train-fashion-MNIST.py. First, import Torch, the neural network module, and the DataLoader. Then load the Fashion-MNIST dataset with Torch Vision. The transform converts every image to a float tensor automatically. Finally, wrap the data in a DataLoader with batch size 64. Your script is ready to run.
When you run the script for the first time, Torch Vision downloads the dataset. You'll see 4 files downloading from the official server, about 30 megabytes in total. Then it extracts them and prints done. Look in your project folder.
You now have a data folder with Fashion-MNIST inside, split into raw and processed. The next run will be instant.
Now let's look at a batch. Each batch holds 64 images, and the shape tells the whole story. N is the batch size 64. C is the channel 1, because the images are grayscale. And H times W is 28 by 28, the image size. Labels come as a simple tensor of 64 integers. The training set has 60,000 images, so each epoch runs 157 batches.
Time to build the model. We define a class that inherits from nn.module. The model flattens each image, then passes it through 3 linear layers, 784 inputs, then 512, then 512, then 10 outputs, 1 output per class. Between the layers, ReLU adds nonlinearity. Here's the model, printed layer by layer in your terminal. Training needs 2 more pieces. First, a loss function. Cross-entropy loss compares the model's 10 scores with the true label, and a small loss means a good guess. Second, an optimizer. Stochastic gradient descent with a learning rate of 0.001.
It nudges every weight toward lower loss. Then the loop begins. Predict, measure loss, backpropagate, and update. Repeat for every batch.
Now we train. Watch the loss go down, epoch after epoch. It starts at 2.3, which is random guessing. After 5 epochs, it's below 0.5.
Every epoch ends with a test on 10,000 unseen images, and the accuracy climbs from around 58% to over 88%. On a normal computer, 5 epochs take about a minute.
Let's evaluate the final model. It never saw the test images during training. Accuracy is 88.2%, and average loss is 0.42. Some classes are easier than others. Trousers, sandals, and bags reach around 97%. Shirts are the hardest, at about 70%. Not bad for a first neural network. Finally, save your model. One line writes the weights to model.pth, about 2.7 megabytes. To use it, load the file back and feed in a single image. The network outputs 10 confidence scores, and the highest one wins. Our test image?
An ankle boot at 99.3% confidence. And the true label? Ankle boot. Correct.
Want it faster? With an NVIDIA GPU, PyTorch prints using CUDA device and training can be 10 to 50 times faster. If you hit an error, here are the fixes. Shape mismatch? Flatten your input first. Device mismatch? Move everything to the same device. Wrong data type?
Cast to float 32. Your first AI is trained. Like, subscribe, and comment. Happy building!